one of the original founders of the Mars Underground at the University of Colorado in 1981, which began the movement that ultimately resulted in the Mars Society. She was a grad student at University of Colorado then, but subsequently went to NASA Ames, where she became a research scientist, working on various technologies associated with Mars exploration. And in fact, I believe she has a talk tomorrow in which she's going to talk about some of her own technical work in that area concerning drilling on Mars. But tonight, what she's going to do is review the latest discoveries in Mars exploration, because, you know, since 1996, we've had a string of mostly successful probes going to Mars, and they've made a string of discoveries which collectively have really altered our picture as to what we might find on Mars and what there is to be discovered on Mars. And while we've had a variety of presentations here at this conference covering one or another, I think it's important that it be pulled together. And so, Carol Stoker.
Well, I'm very honored to have been on the same podium with Jack Schmidt, one of the greatest American heroes alive today. What's new on Mars? One of the things that's new is actually old. This is I don't know if we're going to be able to hear this. It's a little clip out of the 1964 science fiction movie that was 1964, prior to the very first Mars mission, prior to Mariner 7. Robinson Crusoe on Mars made an incredible prediction. So unfortunately, I'm afraid you can't hear it. So what he's saying is, what are these yellow rocks? Why do they burn like coal? They seem to be full of oxygen. I have to store them. Unfortunately, the sound is not being picked up. I was afraid of that. He's sitting next to a fire where he's burning these rocks. So here we are in 2013. Danny Glavin, as one of the SAM observations, reported the presence of perchlorate. It was actually confirming an earlier discovery of perchlorate from Mike Hecht, who was part of the Phoenix mission discovery. So both these papers indicate that there's approximately 1% by mass perchlorate on the surface of Mars. Well, why is that interesting? This is the chemical formula for perchlorate. As you can see, there's a chlorine molecule, 4 oxygen molecules, and up to 8 water molecules. At the eutectic mixture, so this is a salt. You can mix water and salt together until you can't mix any more salt into the water. That's the eutectic. At the eutectic, perchlorate will lower the freezing point of water to -68°C. This is a low enough temperature to make water flow on most of the surface of Mars today. It is a very highly hygroscopic, produces what's called deliquescence. What that means is that at lower than 100% relative humidity, it will cause water to condense onto the perchlorate grains. You can actually watch this in a microscope. You can watch as the humidity increases up to about 50%, the crystals of perchlorate start to swell and become water drops. It is a very strong oxidant. It can oxidize organic matter, and as you'll see, it can explain a lot of what else we've been seeing. It can be used as an oxidant for rocket fuel. In fact, it is used for that on Earth. And very importantly, it's an energy source for microbial metabolism. Many microbes can eat it. So, next big discovery, nitrates. One of the interesting things about is a lot of these big new discoveries, the first author of the papers are young, early career researchers, women. Something I'm personally very fond of. So Jen Stern actually talked about this today. She was a speaker. That nitrate has been identified. definitively in the drill samples, and actually some of the finds that weren't drilled at the Curiosity, in the Curiosity rover traverse. The average concentration, kind of average of these numbers down here, is 300 parts per million. And that's the wind-blown dust, so it isn't necessarily even have to go underground. There are nitrates in the soil. That's important. Why is that interesting? Well, nitrate is a form of fixed nitrogen, meaning it's not nitrogen gas. Fixed nitrogen is very important for life. When you put fertilizer on your garden, it's got nitrate in it, almost certainly. There are some microbes that can fix nitrogen, but it's not every microbe, and it takes a lot of energy. There are very specialized microbes that can do it. But because Mars has only 2% nitrogen in its atmosphere versus 80% on Earth, the availability of fixed nitrogen was often in question. In fact, when I was a graduate student, Penny Boston was doing experiments trying to determine could microbes fix nitrogen at 2% concentration. So it's, the availability of fixed nitrogen is important for assessing the habitability of Mars. However, nitrate is not terribly surprising because it has been seen in the Martian meteorites. Phoenix had the intention to measure nitrate, but the measurement was foiled by the presence of perchlorate. It turned out the nitrate electrode was also sensitive to perchlorate. So, in fact, nitrate is less abundant than perchlorate. On Earth, perchlorate and nitrate actually are found in a constant ratio almost everywhere on Earth. In the Atacama, there's more than in other kinds of soils. So 10,000 nitrates for every perchlorate. On Mars, it's actually the other way around. There are 100 perchlorates for every nitrate, at least based on that observation. So, discovery number 3. Methane. Curiosity rover detects variable levels of methane on Mars. And I should point out again, this is the most current detection. Peter Webster and the SAM team in Science in 2015 found a background level of just about a part per billion, but a variable level of 5 to 10 parts per billion. High methane was detected on 4 separate observations over a 60-sol period. So what this is doing is this is taking the SAM instrument and just sucking in atmosphere and measuring what's in the atmosphere. And boom, there's methane in the atmosphere. There had been previous reports going all the way back to Mars Express in 2004, ground-based, a couple of ground-based observations that had reported it. And every time the community sort of questioned, can this be for real? This has got to be instrumental error, this has got to be noise, this just can't possibly be what we're seeing. Well, why is it interesting? It's produced biologically. It can be produced abiologically in a reaction called the serpentinization reaction, which is a water rock reaction with certain kind of mineral, serpentine. But it is, actually means there's got to be that rock and water around. Methane from either source could be stored and episodically vented. The lifetime of methane in the Mars atmosphere to ultraviolet destruction is 300 years. Due to wind, any local methane plume should be quickly globalized. So varying methane signatures are very puzzling. Why should the methane go up and down? It has to be plumes. The only way that you could get an exogenous source to explain the observation from Curiosity is if you had a sort of an unrealistic scenario where you brought in a bolide that had a lot of methane in it and 1% was released over 60 sols. It would have to happen in Gale Crater, and there's no recent crater, which you can see from HiRISE. So the variable methane is best explained by occasional local plumes, and they have to be in Gale Crater. So, the next big discovery, organics found on Mars. So this is red Mars, this is gray Mars. Drill holes in the sheet bed mudstone show that the material below the surface is actually not oxidized, it's reduced. And the analysis from the Chemin instrument shows that they're both oxidized and reduced phases of iron and sulfur minerals. The organics, the understanding of the organics and the presence of organics and finally getting a paper published on this fell to a young early career researcher at Goddard named Carolyn Frissonnet, a postdoc, who had to try to unravel the very complicated set of reactions that are going on between the samples and the perchlorate in the samples, because the way the SAM instrument works is it brings in the sample and it heats up. It's actually the same way the Viking GCMS worked. You bring in the sample, you volatilize it with heat, and when you volatilize organics in the presence of perchlorate, they burn. Exactly like predicted in the movie from 1964. So it took a lot of working with the data to reproduce and show that in blanks you could actually get more of this reaction product, which is these chlorinated hydrocarbon compounds, then you would get more from the sample than you would get from blanks. And so kudos to Carolyn Frissonnet for working it out. The samples, the rock nest sample doesn't show any. The rock nest sample is a fine just scooped up off the ground. Some of the other drill holes don't seem to show it either, but one of them seems to show it quite convincingly. So one of the things that I find puzzling is that John Klein, which is one of the drill holes, and Cumberland, which is another, were only 2 meters apart. One of them seems to show convincingly organics and the other does not. So that's a puzzle. So why is organics interesting? Well, as Gil Levin has pointed out, it was actually the non-detection of organics that led to the interpretation of the Viking biology experiments as not resulting from life. Again, resulting from thermal volatilization. In 2010, Rafael Navarro-Gonzalez and colleagues suggested that the Viking chlorinated hydrocarbons were actually a result of organics reacting with perchlorate. And that, I think, has been borne out by what the SAM organic instrument is seeing. The SAM organic analysis, however, is even more complicated because realizing that this reaction with perchlorate might become an issue, the SAM team brought a very, very complex organic molecule that was supposed to be used to extract the organics out of the soil. This is the organic molecule. Well, it turns out that the cuvettes that they brought with them of this organic molecule have leaked. So the instrument itself is contaminated, and figuring out what is noise and what is signal has been a very, very tough job. But at least the evidence now is pretty strong that they are seeing organics in the samples. Okay, discovery number 5. This is rocks with very high concentrations of manganese oxide are found on Mars. This shows detection is with the ChemCam instrument, and once again, the lead author on the paper is an early career female researcher at Los Alamos. What they are seeing,